Okay, so in this lesson we're going to talk about pure imaginary numbers and just kind of a history lesson here. We're not going to talk too much about it. If you want to look in your book on page 421, it talks more of a history about these imaginary numbers and where this concept came from. But what was happening was mathematicians started getting answers like this. When you use the quadratic formula, sometimes this happens, or just in solving simple equations, sometimes this would happen, where you get the square root of a negative number. Well, if you tried to solve this on your calculator is going to get upset with you, and it's going to tell you that there's no real solution here, which is true. So there's got to be another possible way to get around this. And so what mathematicians did is they came up with this concept of imaginary numbers. Again, they're not coming up with, they weren't so bored and so isolated where they didn't have any friends, where they had to invent imaginary numbers. That's not the point here. Imaginary numbers come from this idea that we cannot take the square root of a negative number. So they came up with this concept of this I down here is going to be equal to the square root of negative 1. So it's the same kind of idea of pi, where we know that pi is 3.14159, and it keeps going on and on. We're going to use the letter I to represent the square root of negative 1. So now if we have a problem like this, like the square root of negative 25, we know that the square root of negative 25 could also be written then as the square root of negative 1 times the square root of 25. And if I know now that the value of square root of negative 1 is the same as I can rewrite this as I times the square root of 25, and square root of 25 is 5, so my answer would be 5i. So square root of negative 25 simplifies to be 5i. Now you don't have to, what I wrote down here in purple, you don't have to write that down every single time. But that's kind of what's going on here. Square root of negative 25 is always going to be the same as the square root of negative 1 times the square root of 25. A faster way to approach this problem is to go directly from square root of negative 25 to this. In other words, anytime we take the square root of a negative number, that's not okay. It's not possible for me to do anything with the square root of a negative number. So to make it positive, we pull an I out. We pull an I out front, so it's going to be I to the square root of 25. And now the square root of 25 is 5, so we would have 5i as our answer. Now before we go any further, I also want to talk about this other major concept. So there's two key concepts for today's lesson. The first is that what I highlighted and circled there is that I is the same as the square root of negative 1. The other concept is that I squared equals negative 1. Well, why is that? Well, if you look over here, just to review some basics, if I take the square root of 2 and square it, the square root and the square undo each other, so I'm left with 2 as my answer. Or if I have the square root of 3 and I square that, well, the square and the square root undo each other, so I get 3 as my answer. So if I had the square root of negative 1 and I squared that, well, my answer would be negative 1. Well, since we know from this rule, I is the same as the square root of negative 1, so I squared would equal negative 1. So those are our two main concepts, is that I squared equals negative 1, and I is the same as the square root of negative 1. We're going to get to this concept, the second concept here about I squared being negative 1 in a minute. But let's simplify this one. Square root of negative 49. Again, if we approach a problem like this, and we have the square root of a negative number, that's not possible, so I take out an I, so I'm left with I squared of 49. Square root of 49 is 7, so my answer would be just 7i. Now before we look at this other example, let's look down here at these other examples. So we're going to talk about some operations and some different properties of imaginary numbers. And in reality, the properties that we're working with are the same properties that we already know about addition, multiplication, subtraction, division, when we're using variables. Except for the only difference, we treat I as any other variable, with the only exception being that the square root of I, I'm sorry, not square root. If I ever have I squared, that's going to be equal to negative 1. That is a key piece of information that's necessary for us to know how to do these types of problems. So let's do this first one. So 5i times 3i. Well, just like 5x times 3x would be 15x squared, 5i times 3i would be 15i squared. Well, we just said I squared is the same as negative 1. So 15 times I squared would be the same as 15 times negative 1, which we know would be negative 15. So 5I times 3I would be negative 15. Let's look at another one. Here I have the square root of negative 16 minus the square root of negative 64. Well, the square root of a negative number I can't do anything with unless I take out an I. So it's I square root of 16 minus I square root of 64. Square root of 16 is 4, so this is going to be 4I. Square root of 64 is 8, so it's going to be 8I. And 4I, take away 8I, well, that's negative 4I. So so the square root of negative 16 minus the square root of negative 64 gives me negative 4I. Let's look at letter C here. With this one, I have square root of negative 2 plus square root of negative 2. Again, I'm going to end up taking out an I from both of these. This would be I square root of 2 plus I square root of 2. Now, when I add these together, these are like terms. So if I had, let's break off for a second. Let's ignore the fact that we have imaginary numbers right now. We'll come back to this in a minute. Let's say if I had 3 square root of 5 plus 4 square root of 5. These are like terms. So 3 square root of 5 plus 4 square root of 5 would give me 7 square root of 5. We wouldn't add what's under the radicals. We wouldn't say it's 7 square root of 10. We would just say, well, there's 3 square roots of 5. Here there's 4 square roots of 5. Together I have 7 square roots of 5, or 7 square root of 5. Applying that concept now to this problem, I square root of 2 plus I square root of 2 means that I have 1 I square root of 2 plus another I square root of 2, giving me 2 I's times the square root of 2, which we could write like this. And that's your answer. There's nothing more you can do to that. Now let's look at this last one. This last one involves division. So again, we can't do anything with the square root of a negative number, so I take out an I. So it's I squared of 100 divided by I squared of 81. Square root of 100 is 10, so this will be 10I. Square root of 81 is 9, so it'll be 9I. And I can cancel out my i's, so I'm left with 10 nights. Okay, I want you guys to try these next 4 examples. So I want you guys pause the video, try these next 4 examples, and hit play when you're ready to check your answers. Okay, so let's check to see what you did here. So when we multiply these together, this one would be 7I times negative 10I. Well, that's negative 70I squared. Remember, I squared is the same as negative 1. Negative 70 times negative 1 gives me a positive 70. Here I have negative square root of negative 25 minus square root of negative 100. Again, ignore the fact that there's a negative right there. That doesn't change the fact that I have to take out an I. So it's going to be negative I square root of 25 minus I square root of 100. Square root of 25 is 5, so it'll be negative 5I. Square root of 100 is 10, so it'll be minus 10I. So your answer here would be negative 15I. This next one, I would take out an I, so it would be I squared of 3. Take out an I from this one, giving me I squared of 3. Add those together, I have 2 i's times the square root of 3. And lastly, I would have I squared of 25 over I squared of 64. Square root of 25 is 5, so it'll be 5I. Square root of 64 is 8, so it'll be 8I. So my answer would be 5/8. Okay, so let's look at one more type of problem. That being if we have a problem like this, x squared equals negative 900. Now this is going to tie together what we talked about at the very beginning of this chapter in lesson 6.1. The fact that if I solve this problem, I already have the x squared by itself, so I want to find out what x equals. So I take the square root of both sides. The problem with that is the square root of x squared is not x. It's the absolute value of x. Meaning that I'm going to have 2 solutions here. I'm going to have x could equal a positive and a negative. I'm just going to go ahead and take out an I now. So positive and a negative, I times the square root of 900. So now I have to figure out what the square root of 900 is. Now there's a couple of different ways we could do this. One way is using this idea of perfect squares. Now this way is the easiest way, but it requires us to memorize this table, and or you have to write out this table. So here's the table that I'm referring to. The fact that 1 squared equals 1, 2 squared equals 4, 3 squared equals 9. 4 squared equals 16. 5 squared equals 25. And so on. Okay. Okay. So looking at these numbers here, these are all my perfect squares going from 1 through 44. Meaning if I look at 36 here, the square root of 36 would be 6. Or if I look at 81, the square root of 81 would be 9. So what we're doing here is, let's go back to this problem now. We have plus or minus the square root of 900. So to figure out what our answer would be here, I know that the square root of 900 is made up of two perfect squares. 9 times 100. So that plus or minus I times the square root of 9 times 100. Square root of 9 is 3. Square root of 100 is 10. Well, 3 times 10 is 30. So my answer here would be a positive or negative 30i. Pretty simple. But what if we had a problem like this one? Square root of negative 225. Where you might not know if two numbers here would multiply together to give me 225. Or if I knew that there were two, how would I know which ones I'd use? So here's another method. That's using what I call a tree diagram. Well, first let's simplify this. So the square root of x squared would take the square root of both sides. So I get the square root of x squared, which is the absolute value of x. So if I just make it easier on myself and say this, that I'd have the absolute value of x, I should say that equals I times the square root of 225, but that means I'm going to have two solutions, a positive and a negative I times the square root of 225. So again, all I've done is I've just, anytime we have an x squared, just remember that you're going to have two possible answers. I took out an I because I can't do anything with the square root of negative 225. Now for this problem, again, we could find two perfect squares or find a perfect square times another number. That would give us 225, but I don't know what two I'd use. So I'm going to use what I call the tree diagram. So I start by trying to find two numbers that multiply together to give me 225. Well, if you don't know, you're going to have to break out old school long division. So 5, we want to see how many times 5 goes into 225. Well, 5 doesn't go into 2, but 5 goes into 22 4 times. Because 5 times 4 is 20. Bring down the 20. We find the difference here. Subtract, and we get 2. Bring down the 5. Well, 5 goes into 25 nicely. It goes another 5 times. So 5 times 45 gives me 225. Well, 5 is a prime number, so I'm going to circle that one. So I'm going to break down 45. 45 breaks down to be 5 times 9. And 9 breaks down to be 3 times 3. So now when I go to simplify this, square root of 225, here's what I do. For every two of the same number, I get to take one out of the radical. So the fact that I have a 5 and a 5 means I could take out a 5. And a 3 and a 3 means I could take out a 3, so I get 15. So in other words, x equals a positive and negative 15i. The square root of 225, square root of 225 is going to be 15. This isn't going to be a huge emphasis right now, but you do need to know how to factor things down if you don't know what the square root is. That'll help with some of the problems in your homework assignment. So hopefully you have a better understanding and you know how to use imaginary numbers. Again, the key is here. The biggest key is the fact that I squared is equal to negative 1, and that in reality I is the same as the square root of negative 1. So good luck on that assignment.